Uh, very good evening to all of you. I am J. Umar Mohammed, Assistant Professor from Tiarja College of Engineering. We are coordinating this webinar on digital manufacturing. First, we start with the welcome address. Very good evening to all of you and a warm greeting on behalf of management, principal, head of the Department of Mechanical Engineering. Today, we have a chief guest for this webinar section on digital manufacturing, Mr. Rohit S. Mallaya, Head Emerging Technology, PLM, Indus Technologies, Bangalore. It gives me immense pleasure in welcoming our chief guest, Mr. Rohit S. Mallaya. We welcome you, sir. We have another resource person, Mr. Pratik Naval Pakam, founder and principal consultant of Honey Home Consultants, Chennai. We also welcome you, sir. He is also going to share his ideas and suggestions in this session. Today, the chief guest, Mr. Rohit S. Mallaya, has more than 11 years of experience in the field of management. He is very proficient in managing digital transformation projects and finding business opportunity across all markets. Moreover, he was one of our chief guests for our mechanical technical symposium TechSouth during the academic year 2019-20. Next, I would like to give a warm welcome to our beloved college registrar as well as head of department of mechanical engineering, Dr. K. Chokalingam sir. Then I like to give a warm welcome to all deans, faculty members, and students of our college for this wonderful webinar. Finally, I would like to give a warm welcome to HODs, faculty members, and students of other various engineering college in and around Tamil Nadu, like Government College of Engineering, Tirunelveli, PhD College of Technology, Coimbatore, Velamar Engineering College, Madurai, PSR Engineering College, Sivasi, Bannariamman Institute of Technology, Satyamangalam, Savita Engineering College, Vailtech Institute of Science and Technology and Advanced Studies, St. Peter College of Engineering Technology, Kamaraj College of Engineering Technology, Madurai, National Engineering College, Kovilpatti, Karpam Institute of Technology, Coimbatore, IMT College of Engineering from Noida. We also have some participants from polytechnics like Government Polytechnic, Nizam, PSR Polytechnic College, Mohammed Sadar Polytechnic College. Once again, I extend my hearty welcome to you all for this webinar section. Thank you, everybody. Now I invite our college registrar as well as head of department of mechanical engineering, Dr. K. Chokalingam sir, to give facilitation address. Thank you, sir. Over to Dr.
Thank you. Thank you, Umar. Whether my voice is audible?
Audible, sir. Audible.
Yes, sir. Yes, sir.
So, good evening, everyone. Especially my special thanks to Rohit Mallaya and Pradeep for their wonderful sparing his time with us through this webinar on digital manufacturing. Thank you, sir. I also express my sincere thanks to all the participants who is attending this particular seminar webinar for sparing their time. Actually, if you talk about because I would think this particular topic, the digital manufacturing is the order of the day. So if you see the various definition, it is nothing but of the digital manufacturing is nothing but of an integrated approach of manufacturing. That will be centered around the computer system. So when you are adapting this digital manufacturing, the constraint on the 1994 in India, there was a tremendous change has been took place in the manufacturing sector. So the people who is in the age of 50 and above, they can understand that during those days before 94, if we take the four-wheeler light motor vehicle, we can see only the Hindustan Motor Ambassador and then Premier Auto Limited Badmini. These are the two major vehicle on the road, and we couldn't find any more vehicle. What we are seeing now, just like a Ford, Hyundai, and so on. So in this 1994, opened the market through the globalization. Many of the foreign manufacturers came into the India, and there onwards the characteristics of the product itself changed very well. So in the globalized environment, the product will become a shorter span of life, and it has the customer driven, and then more specific to the cost and so on. So these are all able to achieve only because of the digital manufacturing. Addition to that, I wish to say one point here is previously the market was a seller's market. Then after 94, in most of the cases, it becomes a buyer's market. The buyers dictate the terms and conditions. So what happened? The general product uh, your ambassador and all, then because of the customer driven market or seller buyers market, then customized product is came into the picture. Now what happened, the advancement is taking place in 18 and 19 onwards. The customized product become a personalized product. Good example is if you want to have a personalized product, the hearing aid, which is from now it is manufacturing for each and every person of the earlobe. So now the product, if you see the growth of the pattern, so previously general product, then customized product, now it become a personalized product. So when you want to satisfy this personalized product market, the digital manufacturing is the only way. So digital manufacturing will cover all the subdomains of the manufacturing, say design process, and then vendor selection, and then supply chain, and then inventory, and then process control, and then marketing, and then sales and service. All the spectrum has to be individualized, and it will become efficiently handled only through digital marketing. As in that sense, this digital marketing, digital manufacturing become one of the key element in this area. And we can say that the design will happen one place, maybe in China, and our manufacturing maybe happen in India, and then marketing will happen in European country and so on. So in these circumstances, the distance should not constraint for us, and then data transfer from one place to another should not be a constraint for us. For example, if you take the manufacturing, the CNC machine, and so on, and the program has to be written, and the program has to be transferred from one place to another, and it has to run, and the part is to be produced. In that circumstances, this digital manufacturing is the only solution for meet of the customer based, personalized based product development or product manufacturing. So in that sense, I would like to thank the Rohit Mallaya. He's come forward to give the lecture on digital manufacturing, which is order of the day, sir. Thank you very much.
Right.
With this brief introduction about the digital manufacturing, I hand over the floor to you, sir. Thank you very much.
Thank you. Thanks a lot. Thanks for giving us this opportunity from both my side and Pratik's side. And we are really looking forward to share our views of what we have understood of digital manufacturing and how it is going to really redefine the times to come. So that's what we are planning to cover in the next 1 hour's duration. Okay. So
before starting the webinar, I want to introduce our chief guest, Mr. Rohit Mallaya. Our chief guest, Rohit Mallaya, computer is BE in Mechanical Engineering from Satyabama Institute of Science and Technology, Chennai, during the year 2002 to 2006. He also has completed his MTech in Industrial Engineering from PSG, the College of Technology, Coimbatore, during the year 2006 to 2008. Before joining Indus Technologies, he has been working in Renault software for more than 11 years, from the year to June 2008 to February 2020. In the Renault software, he had been in various positions like pre-sales support, industrialization, technical support, engineer, senior application specialist. Finally, he was a manager technical marketing. Currently, he is working as a head emerging technologies in PLM, Indus Technology Private Limited, and is responsible for his company operation in and India. Some more important highlight of our speaker is that he is more expertise in domain of engineering and manufacturing solution, automotive, OEM, railways, defense, space research, auto supplier, industrial machineries, line builders, food and beverage. He also has worked in areas like layout design, discrete event simulation, robotic simulation, and ergonomics. These engagement help his customer to identify the possible opportunity for productive improvement and get started on the way of Industrial 4.0. With all this, I heartily invite Mr. Rohit Malaya to deliver his presentation to the participants. Thank you, sir.
Thank you. Thank you.
Over
Thanks
to
for that. Welcome. So I
thank
hope my screen is visible to all.
Yes, sir. Yes, sir.
yes, sir.
Perfect. So as we heard that we are looking at digital manufacturing as a technology which will help us to get things done faster, maybe in a global perspective, maybe to customize our products. So it essentially is going to help you accelerate your manufacturing. And that's what Prateek and myself is going to take you through in the next 1 hour's time. So what has changed over the years? Time has started going very fast, and the number of people. I think this video was captured in the pre-COVID times. Okay, that's why we are seeing so many people on the floor. But otherwise, I think we would today, if we go into the streets, we wouldn't be seeing so many vehicles or people. But anyway, this is what was thought about as the future, and but it's getting redefined to a new normal, which is something that is more interesting and looking to be better as I see. So what has happened? There is devices everywhere, and there is a lot of data that is getting captured from these devices. So what Ray Kurzweil says is that we won't experience 100 years of progress in 21st century. It will be more like 20,000 years of progress at today's rate. Why is that? There are so many devices which are connected, and there is much more today. If you look at everything, like you take an example of a house, there are smart devices in the houses, like lights are smart. There is Alexa, which is your voice enabled assistants which are there. Your cars are getting smarter. So all your products, be it in your personal life or in your industrial world, is uh, getting connected. And when they get connected, it is going to become more uh, challenging. Okay, sorry. So we are witnessing what we are witnessing is a battle for future for many of our businesses, and this stays relevant because what was working well is not working anymore. We don't see ambassadors on the road. We don't see Nokia phones as frequently as what it was many years back. So that's again getting changed. And now when this data is getting generated, how do we make sense out of this data? That means there's going to be a lot more of changes in the way that we make these products and use these products. So what is going to happen? We are going to start looking at additive manufacturing. We are going to start looking at generative design, IoT, artificial intelligence, and analytics. So which essentially means that our products are going to get more and more complex, and that is where it is becoming more important for us to have different kinds of platform which will help us take these decisions. Now, before we get to understand what is digital manufacturing and why is it important to us, let's start looking at the product life cycle, which we are all comfortable. So there has to be a product design, there has to be a production planning, and finally, there has to be the production execution or the operations phase. Now, this is something that we are all familiar and we have been hearing through our engineering days and in the all the classes. Now, what is going to change? Why is this very important? So when we look at it today, what we covered with digital manufacturing is going to be of the production planning and engineering. And tomorrow, what Pratik is going to predominantly cover is going to be more about how virtual and digital tools are going to cover in the space of product design as well, and right from there to the end of the journey, including the later phases. So when we start conceptualizing a product, we use a CAD platform to create a 3D model of this product. Okay, and then we design it for, we check for the manufacturability of it, we check it from the quality perspective, and finally we pass it on to the manufacturing phase. Again, here there are different steps that is involved. One is, how are you going to manufacture this product with respect to the processes? What kind of processes is the product going to evolve from? That is, from the raw material to the finished good. How is it going to transform? What are going to be the activities that is going to get involved in it? And what is the outcome of each of it? Now, when we look at process planning, typically we use Excel files or we use snapshots using PPTs, which help us to define what is the manufacturing process. Now, post that, what happens is that there is a mock-up that happens, which is again based on the kind of expertise that is available with the engineers in the team. That based on that, we define what is going to be the layout, and we develop 2D layouts of how the plant is going to look like, how the assembly line, machining line, the quality lines, and the packaging lines are going to look. Now, post that, we also start looking at what are going to be the problems, and then start executing the production. This is the typical uh, process that is being followed. But with digitalization coming into play, what is going to change is all of this is going to happen. There's no other way around for it. But we are going to make use of softwares like how we make use of CAD softwares like your Solid Edge or SolidWorks or your CATIA or NX. For doing the design, we will start making use of some softwares. Let us keep that part of what is the name of these softwares for a later part, but essentially that is what is going to happen. And with the help of this, we are going to start looking at designing the products. Now, when this happens, what is going to change? We can look at mass customization. We can look at having parts done in designed in one location and manufactured in another location. And also, we can improve the quality and predictability of the overall operations. So let's take a bit more of a deep dive into what kind of activities get involved. Now, BOM is bill of material, which is essentially required of how the part is going to get transformed from the designed product into the manufactured product, which is your manufacturing bill of material. We spoke about the process planning, which talks about how the part is going to get manufactured, and process validation is going to take care of how these parts are going to get assembled. Can we visualize how two parts will go and fit into each other? And if they fit in, is it going to fit in rightly? And what kind of tools is needed for them to do this activity? Now, suppose that this data that we used in the process validation can be reused for your work instructions. Today, what again happens here is there are photos which is captured, and these photos are used as your work instructions. If a new engineer comes to work, he's not going to be able to visualize what is the angle in which he has to hold, how should he orient the parts, and how should he fit the parts in. Now that means that he's going to take time to learn, and how do we help in reducing this time that is spent. Also, there is time involved in production planning, that is what should be the sequence in which parts get loaded, how can we avoid the wastage of time that is related to setup and changeovers. Now, with all this, we call it as a manufacturing information management system. Okay, because like how we hear about product, how we hear about a ERP or a PLM, we also need to manage the manufacturing related information, which is what we will essentially talk about or do by utilizing digital tools, and that is what we will start looking in the coming slides. So today, another thing which happens in the industries is there are different teams which are working on it, like the ideation or the design is created by a team which might be, say, for example, situated in Madurai. The manufacturing process can get defined by a team which is situated at a different location. Let's take, for example, Chennai. And the final manufacturing might be happening in a different location, which let's take, for example, is Bangalore. Now, three teams sitting at three different locations, how will they communicate correctly, visualize correctly, and take the decisions correctly? It's not going to happen, right? Today, when we look at the COVID scenario, everyone was forced to work from home. Okay, we couldn't sit in a room and have a discussion about how are we gonna, what can be the problems, where the problems are gonna arise, whether the fitment is gonna be right, whether the manufacturing process, what is being selected is correct, what, how is this gonna happen? This is not gonna happen anymore, and this is the new normal. That is, a lot of discussions are going to happen using web tools like Zoom or Teams or anything else, and decisions need to be taken. Can you imagine taking these decisions using a 2D? No, right? So that is where digital manufacturing is going to play more and more uh, importance about helping companies survive the current stages and become profitable and sustain. So these three need to start talking to each other, need to interact with each other in a way that is efficient. And this this how this will happen is by having a platform that is gonna make this realize. Now, before we get there, let's Choklingam sir was talking about getting products to the market at a shorter time, then the competition, then the cost pressures, the changing customer taste. We spoke about the product complexity, globally dispersed teams, ability to adapt, and ongoing improvement initiatives. Now, out of this, I would say it is very important for a company to be adaptable. And that's the way the companies are going to be able to achieve all of the other points. If we look at it, why? Because the taste of the customer is going to keep changing, and we cannot keep testing these new concepts on a manufacturing line by stopping production, by taking the feedback. Now, at the same time, if we are able to make use of digital platforms which are going to help us uh, use these, like today if you look at it, everything companies are trying to push their products using digital marketing. You can see a lot of YouTube ads. As we are watching the YouTube videos, there's a lot of ad which keeps coming in. So there's a lot of push towards digitally doing things and taking the feedback from the customers, taking the feedback from the market about their liking to the product. And if we are able to also utilize technology to make things in a faster manner, we will be able to achieve more of this. And we are talking about getting more projects or more manufacturing happening in India locally, and which of MNCs who are spread across different markets. Now, all of this is the trends and the product changes and the customer behavior that is changing. And to achieve all of this, it is becoming more and more imperative that we have a platform which is going to be helpful for customers to visualize. So that is where, as students, where we should start looking at is how do we get enabled on some of these tools where we can do projects on utilizing these technologies to do our projects, do concepts for companies which are in our localities, and help them win projects or scale up their operations, identify where is the value added areas, where is the non value added areas, uh, and take it up to the next stages. So we and what is needed for companies to stay relevant is what is needed. And they need to establish processes. They need to find ways in which they are able to reuse more data. They used to move. They need to move from expertise to data-driven decision making, and how they can achieve first time right, capture all the knowledge that has been gained over the period, and also communicate efficiently to the different team members. Now, we spoke about working from home, working from globally dispersed locations, and all of this means that it becomes uh, digitalization and digital technologies are gonna play or the change maker for the times to come. Now, how have things changed? Okay, so in the earlier days, maybe 1930s, 1940s, I would say 1970s also, it was fixed and manual work. Okay, now today, do you think people can sit so close and do activity? I don't think. We are talking to a lot of customers who are saying that uh, help us automate, help us uh, do things without being dependent on people, because that's the mandate that they are looking at. They don't find people working close to each other very safe from the COVID perspective. And COVID, if you look at it, it is going to stay. And once it becomes a habit and customer starts realizing what is the benefits of using these technologies, they are going to look at more of automation. And when automation comes into picture, they need tools which will help them to validate these automation concepts. And that is where in the engineering students need to start looking at ways in which they are skilling themselves to uh, be able to support to the needs of the industry. Like we are talking about fixed automation. That is what we see in the uh, automotive world, where it is all fixed lines which are manufacturing, and still there is automation which is there. At the same time, we are when we start looking at um, the customization of products, like the uh, the health hearing aid that we spoke about, or any other product that, or a shoe. There are shoes which are getting manufactured, which is highly to made to order type. And also, I know a lot of companies are slowly moving towards, instead of made to stock model, they are trying to move towards a make to order. So that means that they also need to be flexible as well as make the decisions in a autonomous manner. So when we start looking at all these concepts, we slowly start realizing that our human brain will not be able to achieve all these requirements on a pen and paper or by visualizing it in a 2D environment. Now we spoke about what are different points, and we looked at the complexities that is coming in, the adaptability that is needed. Now I'm sure a lot of you would have started having views about what is digital manufacturing. Okay. Now with this in mind, let's take a look at what are the what do you think is digital manufacturing? So to me, it is a virtual model of your manufacturing facility, not just limited to your what is happening in your production plant, but it can be right from your uh, raw material to the end of the uh, last part of it. Okay. So now when we look at that part of it, It's a virtual logical model to analyze a manufacturing system. So why is it needed? It is needed to do a virtual validation. What are we validating? We are visualizing the human, robot, and the material handling systems. And why is it needed? Because we need to take decisions. I think few of the candidates have raised hand. Maybe if you can just type in your questions, that would be helpful. And we will try answering it as we move forward, if that's going to be good. So we need to perform these changes in a without disturbing the existing and with the minimal time. Let's look at few of the definitions which is from the uh, digital manufacturing perspective. Uh, so digital manufacturing, as per Siemens, is a use of an integrated computer-based system comprised of simulation, 3D visualization, analytics, and collaboration tools to create product and manufacturing process definitions simultaneously. Wikipedia defines it as digital manufacturing can be defined as an integrated approach to manufacturing that is centered around computer system. And finally, when we look at Cambridge University is talking about application of digital information from multiple sources, format owners for enhancement of manufacturing processes, supply chain, and product. All of them are relevant and are right. Now, as we spoke, we are going to focus on this area of production planning and engineering and how digitalization is going to play a role in this space of this area. Now, first thing which we look at is more from the space of uh, layout line design, because that's where we are conceptualizing the uh, line. Okay, so that's where we are conceptualizing the line in the first phase. So where we start off is in the layouting part of it. So when we look at the layouting, we did speak about what happens in a normal process, right? So what happens is there is a 2D layout. The 2D layout gives us the visualization and we take decisions. But what is the limitation of a 2D layout? The limitation of a 2D layout is we do not know in the 3D space what can be the collisions which happen, and also we are not able to visualize the possible collisions. So let's take, for example, this particular robot. Let me just use the annotation that will help me to. Um, so if you look at this in the 3D space, we will not know where, what is the Z direction for the uh, arms of this robot. And we might get a feeling that it might collide with the conveyor that is on the assembly station that is here. But that is what the 3D helps us to visualize. 3D helps us to visualize that what what is the correct way and where can there be a collision and how these collisions can be avoided, especially with terms of pipings, uh, electrical systems, or any other kind of situation that is coming in. Sorry, there was a power failure at my side. I hope I'm still audible.
Yes, sir.
Yes, sir.
So
Yes, sir, it's audible.
yeah. So so essentially that is what helps us. So we are able to quickly pick up the parts from a library, place these parts, and visualize how the layout is gonna look like, so that we don't have to spend a lot of time in the initial concepts and still achieve what is something that is workable uh, from the concept stage. It also gives us the flexibility to make changes because you have not spent too much of time with respect to doing the activity using a cardboard, or for you to do a mock-up, or to do a prototype. Now all these start helping you in visualizing your models in a much efficient manner and more effectively to discuss. So let's take the example that we spoke about, where different people are sitting at different locations, and how would you use a uh, 3D visualization to explain to your as a design the person who's conceptualizing the line, how would you be able to collaborate with your team members sitting in, say for example, Chennai or in Bangalore, to get this line set up, taking the current situation where you cannot travel. So that is the benefit that we have by having this kind of a platform made available. Okay, so it really makes the life of team members much easier, and it has tools and capabilities which will allow you to reuse the parts. Say for example, you have an existing line that is available uh, in one location. It is very easy for you to reuse the data and visualize it from this perspective. Now we saw that, okay, fine, we have the data that is coming. Okay, that is good, but so what? Okay, it's just static data. Okay, now static data is always not so interesting. But when we look at a manufacturing facility, we spoke about how human interacts with machines and how material handling systems and robots start playing a role. Now just imagine this line or this facility where there is a whole set of machines which are available, and you need to plan for the how the kits need to be made available at the different machines, at what time, how many people is needed for it, how many material handling equipments are needed for it. Do you think it is going to be easy for you to visualize that? I'm sure it is going to be really hard for many of us who are very early in our career to visualize all of this. So that is where, again, uh, having a tool which allows you to visualize how uh, manufacturing can happen, and where how many systems do we need, how many what is going to be the throughput that we are going to achieve, what is the utilization of the robots, is it enough that we have 4 stations, or do we need 10 stations, what is the utilization for these 10 stations, how do we optimize the utilizations, how do we optimize the people which are there on these lines, can we reduce the number of operators, what happens if there is a change in the requirement, how many stations should we run it with. So all of this is something that we start looking at. Also look at it, we are able to know without having the line set up, we know what is the power that is needed, which stations are consuming the maximum powers. Is there a way that we can create a strategy by which we run the power intensive machines during the times where the power rates are the low, and how is it going to give us a cost benefit for it, and are we able to still run the line at the best capacities and capabilities. Now this is again another scenario which becomes interesting for companies to start looking at. Now we saw it more from the well, it's interesting to look at it from the overall perspective, but now let's look at it in a bit more detail. Okay, now we estimated that, okay, we need 10 stations, but can we actually achieve the cycle time for these 10 stations? Okay, what is the work content of these 10 stations? How many operators do we need in these 10 stations? Okay, and how is the work going to be shared between these 10 operators? And also, what is of another interest would be that are they performing it in the right posture? And if the posture is right, are they, is because they are carrying a heavy weight, are they prone to a accident? Now that's again something that is possible to be visualized by using a digital manufacturing tool, which will help customers really visualize, or the the decision makers can take decisions on what kind of changes is needed to be done. And all this we are doing without having to establish a line or do the trials on the manufacturing facility. Okay. Now, this way, uh, the engineers are able to conceptualize, try out multiple works in lesser time, and optimize the production in the right manner. Now, if you give the same video to your the assembler, he will be able to do the activity in a much better manner rather than using a 2D based approach, correct? And also we are getting all the data which is important for us to discuss and make sure that the operator is performing it in the right manner, using all the standard analysis. And if you want to write your own algorithms for the analysis, that is also possible. It also makes sure that you are capturing all the red flags, like where are the problematic areas, and make sure that you're taking the right placement of tools. So here we are seeing this cone, which is nothing but your vision cone and your reachability cone. Now using this, we are able to define where the parts and how these parts needs to be placed in the space. So this is how digital manufacturing is going to make more prominence to in the times to come for the operators to be sure that they are doing it right. Another thing which can also happen is you have designed a line for a uh, female operator, and you want to validate whether a male operator can also perform on it, or you have designed the line for Europe and now you are trying to bring that line to India. Now, can you use the line in India without making any changes, or what are the changes that is needed can be validated with respect to all the areas of vision, view, and the related spaces. Now, here we are also going to look at how. So here we are going to also look at what is the kind of uh, how do we establish a safe working zone. If we look at it, we are seeing three operators who are standing close by, and I'm sure today no manufacturer will want to run their lines like this, because it's surely a no where they need to maintain at least 1 meter space between them. And how are they going to look at it is what we will see here, that with the help of the vision uh, cones. So here we are able to see that all the three are going to collide with each other at some particular time or the other. And if they are going to collide with each other, it is not a safe activity that we are performing. Now we can try out different what ifs to make sure that these operators are, what are the points at which they collide within the zones, and also try to make sure that we are able to avoid these collisions and make the decisions in the without having to really play around with the manufacturing facility. And even before your manufacturing facility is starting, you can start evaluating these concepts. And once your concepts are evaluated, So here you can see that, okay, they are put in shields so that these people are not coming into uh, contact with each other, and still they are able to perform the activities. Now, all these can be conceptualized and also discussed with the people, and based on that, we will be able to take uh, decisions and make the changes uh, uh, in the manufacturing facilities, which will help them to avoid the compliance issues or any other challenges that they are looking to with respect to any collisions or anything else as well. Now we saw how we are impacting the operators. We saw how we are analyzing a line in whole. Now there is also another thing which is important, which is the robots. Okay, so let's look at the robot part. So when we look at the robot, we also need to validate how the robot reachability is going to get achieved. Okay, and so what kind of challenges can be expected? Uh, Whether the path is the most optimum. Two robots can have zones which are marked where they should not come into the same zone at any given point of time. So now all of this can also be visualized and validated using digital tools. There looks to be some issue with the video, so I'll get that. For some reason it's not playing in the mode. I'll just play that after this. Now also we can look at using 3D virtual reality, so wherein we are able to immerse ourselves in a virtual environment to actually have a look and feel of the plant. Okay, navigate around it, uh, view how the robots are going to function, mm, move them around, stand on the robot, sit on the part, and make decisions with respect to the areas. So this is also something that is going to be helpful from, or which is the latest trend from the digital manufacturing perspective. And this helps us to collaborate in a more realistic manner. And I think these tools would start getting more and more used in the days to come from the because of the challenges with respect to uh, what do we call as the uh, problems or the other areas, because of restrictions on travel, because of non-availability of people, the experts being in different geographical locations. So all of this can be avoided, and also we can generate the offline programs right from the tool and then download it on the robot and even validate the robot for the perspective. So now what do we achieve by looking at these tools? Now, before we get to these areas, I would like to pass it on to Prateek to present a couple of slides about a case study that he has been a part of, which will help you to visualize what we saw as different tools. And when we come back, I will also fix the issue uh, with the robotics part, how the robotic solution is going to be helpful. That also I will cover it once we are looking at once Pratik takes us to the case study. So Pratik, you can share the screen.
Yeah. I think you'll probably have to allow me to share.
Okay, just give me a minute. Okay. Okay, I think you should be able to share, Pratik.
Yeah. Okay, so good evening to all, and thanks for listening in. again, I will jump directly to the topic, and I'll be speaking to, I think, some of you and other people tomorrow on the subject of virtual manufacturing. So being in the industry, I've had the privilege to use and also allow my people to use a lot of these tools which Rohit was talking about in order to drive the right decisions for the businesses that I've been part of earlier. And also in some cases say that, yeah, it doesn't make sense to use this tool because the problem was either too simple or in some cases too complex where we had very little time to actually go in and do these detailed type of work. So, that's the difference between ideal situation versus reality that happens on the shop floor. So getting to what I'd like to share today is one case study, which was a very complex project, almost covering many of the topics that Rohit had addressed before. And that's why I think it will be very relevant for the students to listen into this case study. We also saw a lot of questions that were shared earlier, which we will address later on. But then this will help with addressing some of those questions as well. So just a second, let me clear the screen where somebody is trying to annotate. Okay. So this is a case study that was basically taken to, hold on for a second, I apologize, there's something on the screen. Okay, now, go back. Okay. So this was a case study, which was basically a project decided by one of my earlier employers to relocate a huge component from Mexico to India. And the decision was mainly in order to save on the logistics cost. The component itself being voluminous, we were at that point importing a lot of these products which were shipping air, right? Because it's a voluminous product. So it was a project aimed at cost saving, or what we used to call business margin improvement. And there were a lot of expectations because the end product where this particular product or sub-product was imported and integrated into the end product, the market for the end product was a very tough customer, the European market. And it had to deal with operator comfort. Okay. So the person using the end product, as we call the operator there, in Europe and US, comfort to the vehicle driver is very important. So that was more important from the legal perspective also. And this product had a historic benchmark, meaning this was already being supplied for several years from the current location. So there was a lot of customer expectation already in place as a benchmark that had to be met. The other complexity was it had about over 1,250 components that were being sourced from various places across the globe, covering over 400 vendors. In fact, if I remember, it was about 550 vendors or suppliers. So with these challenges, and the other main challenge was there were 5 countries involved in the project that you'll see during the next course of my slides. There were 5 different countries involved into the overall execution of the project. There were 3 design centers. When I say design centers, these are massive, 300 plus type of people sitting there and supporting various products across different cultures. And there were 3 manufacturing centers, one which was making the product, one which was making a sister product, and the third where we were going to make this product, which is India. So this was the level of complexity. And next few slides, I'll explain to you of how we went about it and how we achieved the results. But I don't have a lot of graphics like were shown before in Rohit's slide, but most of the technologies were used, most of the tools were used, which helped us deliver the results. Okay. So the product history, like I said, the original design control about 40 years ago resided in Germany and then was transferred to US. And I don't know, somebody's kind of writing on the screen. So I'll have to go back and remove the annotations. Okay. So, and it was moved to the US, and the manufacturing original location several years ago was in Germany. And that's when, these 2 countries wouldn't talk at that time. And there was a lot of break in terms of the information transfer. And later it got moved to US, and the manufacturing facility from US was moved to Mexico. And it was being 15 years, it was for 10, 12 years, it was made in Mexico and supplied to the other factories worldwide. So this was the history of the project to give you an idea of the complexity. So over the years, as these products were made in Mexico and China, there were a lot of design changes that evolved, and the design control was taken locally, and that was not fed back to the master design center. So this was the status of the project when we took over this project. And as a result of this, what we inherited was an incomplete bill of material, inaccurate bill of material. So we were talking about 1,250 components and its child parts. So it was about 4,000 individual bill of material elements. And we had only a 30% accuracy. Then you could imagine the level of inaccuracy there. And the costing was inaccurate. When your BOM is inaccurate, 400, 550 suppliers there, the costing data was inaccurate. And then the process details were incomplete because each facility was making it their own way. And with the BOM not being relevant, it was very hard to visualize and take control of the process because we were transferring the manufacturing from one location to another. So it was important for us to transfer the know-hows of how the product is assembled. And also with the test specification, there were a lot of specifications which were not there. And hence, it was decided that we'll not be able to manufacture this product. However, given that it was a significant cost saving for the business, we had to take this up and move on. So the way that this was achieved was we started ground up. Obviously, we had like 55 different bill of material versions, after which we evolved the final engineering BOM, as they call it. And we continued to buy that product from the source factory. So that gave us the opportunity to physically validate the BOM as we got better understanding of the elements of the bill of material. And also the CAD models were assimilated from various areas. Okay, so that way we formulated the 3D engineering BOM, as we call it, and with the right engineering framework. When I say engineering framework, the dependencies within the BOM are established. So once we had a good control, 80% control of the BOM, we started doing what we call the M-BOM, or the manufacturing bill of material, where based on the demand we had to produce, these bill of materials are grouped according to the sequence of activity. So including the consumables, the packaging, the station-wise, process-wise, etc. So again, I'm getting some annotation on the screen. So I'll go back. And so I leave this annotation, just ignore that arrow for the moment. And then we established the process sequence. We established a product synchronization chart. I'll give you an example in the next slide of what the product synchronization chart means. And we went through the detailed line design using these digital tools. We used a lot of these digital tools right from, because you have to disintegrate the engineering structure within the BOM when you're trying to regroup your activities within the manufacturing BOM. So we have to rely on engineering or these digital softwares to do that. And once we had the station-wise elements designed, like Rohit was showing in some examples, we actually physically did that. We had a challenge that there was no space in the current factory where we wanted to integrate this product line. So we went through a due diligence of identifying space or through these advanced visualization techniques, where we said, okay, what's the minimal area that's required? Right from mapping the operator zone, the movement zone, the material presentation, the material flow, etc. So keeping all of those in mind, we were then able to get this physical implementation done. And prior to the physical implementation, we had to convince the local management about the fact that this would really work. So we had gone to the extent of doing a virtual reality simulation. That's again what Rohit had shown earlier, where we did a virtual walkthrough within this assembly line to see how this would look like in reality after the assembly line is installed within the existing factory. So obviously it took a lot of efforts to get there, but it was worth the efforts because at the end it delivered the cost savings that was intended and the other complexity of establishing a benchmark factory. So the outcome was we made a benchmark factory within the entire global organization. And to say that, okay, this factory is the benchmark, and most of these standards and processes were established and deployed across the already existing factory. And the other one was we created the local competency. So when it came to this particular product, there was a lot of new things that came in, right from electronics to in-process electronic testings to air condition filling, which was not there, where there was a lot of environmental issues, to what we said, a leak test for the final product. So all of this was able to get achieved because we had implemented effective training methods through these 3D models, through these virtual reality tools that we were able to then establish the local manufacturing competency. And today, I'm happy to say that they are able to, they are at double the production capacity that was established at the time this project was implemented. So as I said, one example of a product synchronization chart for people who are new to this terminology is a visual feel. This is a product just for representation. This was not the product that I talked about earlier, but this is how an engineer today conceives how a product will go together in the assembly, right? You can see earlier we used to draw this on pen and paper just with lines and arrows pointing there, but with the aid of visual technology, digital tools that are there today, the manufacturing engineer sitting virtually is able to visualize the line and convince the stakeholders and discuss with the stakeholders on deriving the optimal solution before implementation. So that saves a lot of time in the overall product development cycle. So Rohit, with that, over to you.
Yeah, thanks, Pratik. I'm sure that was very insightful for all of us to see how in reality these solutions are being put to use, because I think that was one of the questions few of them wanted to understand about how these solutions would help them, and what are the areas in which it can be utilized. So now I have been able to fix the issue with respect to uh, the robotics video. So let's just take a quick look at it. I know I don't want to hold you guys back. I know it has been a tiring day, and it's already 7:30 in the evening, and I'm sure you have had a lot of information. But see, what essentially we are looking at is we are able to validate where is the reachability of the robots, how these welds, whether all the weld spots have been allocated correctly, and what type of weld guns are being used, where is it going to have a collision, and all these reports are available for us to validate in the times to come. Similarly, you are able to generate these as reports and also take decisions based on these uh, reports. Okay, so essentially, what Pratik spoke about, how we are able to digitally validate all these concepts, how we are able to visualize it and take decisions and communicate, will help companies to accelerate their launch times, increase their profitabilities, and extend the time for which the products are in existence, reuse the best practices, and reduce their build costs. So this is the way in which companies start seeing the benefit by having a platform which is for digital manufacturing and digitalization to look at. So what did we get by having all these is that we are able to ensure the accuracy, reduce the inventory cost, improve quality and speed of NPIs, eliminate costly late design changes. Now this is a very important part, not just from the direct cost perspective, but it also makes impact on the customer branding. We keep hearing of Toyota and others who had to recall their parts. Okay, and even if you take the case of Zoom, even they had their own challenges with respect to problems getting identified, but because it was a software, it was very easy. They just had to deploy it and it got passed on to all the locations. But that wouldn't be the case in case of a hardware. Okay, when it's a hardware, you really have to call it back into your plant and then make the changes or take a decision of how do you make these changes and go. Minimize the delays and rework, improve utilization and throughput, provide standardization and accessibility, and increase reuse of information. So, so this is the way companies would start looking at it, and to achieve something called as a digital twin, which is a replica of your manufacturing facility, and that can be achieved by utilizing the digital manufacturing tools, which help them to plan and validate the processes, validate the process, define, validate, and do the change management. They are able to optimize the production scheduling and the work instructions, which is helping them to be better in manufacturing, and finally organize the data for the reuse. Now, so let's take the questions now before we close the session. Okay, so maybe Pratik, you want to take those few questions which had been shared over the mail? Okay, yeah, I've given you the permission to unmute.
Yeah, so I have summarized the questions. Let me share my screen because the questions are there, or I'll read out the questions. That might make it easier also. So the first question that we had was about the future scope of digital manufacturing. Okay, so I think, Mr. Umar, this was the first question in the list that you had shared earlier. So we can go by the sequence of those questions, right?
Yeah, I think that's good. Okay.
So what is the future and scope of digital manufacturing? Obviously, we have covered a lot of things today during this session that might give you a good perspective to this question. And a couple of comments I'll add is that digital manufacturing is certainly of great relevance today, and it will remain for the next few years. And over the past 10 years, again, what I've seen is that there's been a lot of rapid efforts which have evolved to support this platform in terms of the overall data handling, storage, processing capabilities, because that's one of the that used to be one of the fundamental roadblocks. The other one is in terms of the input gathering, because let's say, for example, we want to model a factory in 3D, right? That's the first stage of digital manufacturing when you start implementing it. So there, it used to take a lot of time to get the physical data measured and modeled and all of that. So now there's a lot of efforts gone into with 3D scanning capabilities, etc. In fact, drones, as recent what I read, where there's a lot of speed and accuracy of input gathering. And there's also a near to practical simulation of the real world scenario that has been possible because of better accuracies of input capturing. So the other comment I had there was, while virtual reality and augmented reality capabilities continue to evolve, the AR is continuing to evolve. I'm sure they would find ways to replace the current redundant and conventional modes of information visualizing and training, because those are the two primary focus areas for VR and AR at this moment. Okay. The second question we had was career skills to be learned on digital manufacturing. Rohit, I would leave the answer to you.
Yeah. So when you look at digital manufacturing today, I don't think there are too many colleges which are really teaching what is digital manufacturing. And that's where, as an initiative, what we are trying to create is some amount of training, which is a mix of both domain expertise and hands-on softwares. If you look at the leaders, there are different products for digital manufacturing. You have Siemens, who is a market leader in this space. You have solutions from other companies like Dassault has Visual Components, and many others. Okay. Now that is where we are trying to put together a course which is going to be helpful for the students to see where you can take up and how do you get onto this digital manufacturing as a perspective. And also very recently, I noticed that Coursera also has a course on digital manufacturing, which is available.
Yeah, and just one more word of advice for all the students who are listening in. I always believe that one of the fundamental skills for any engineer is the basic engineering skill sets. Okay. So while it's very easy to get carried away with the digital trend, I would strongly encourage all of you to focus on the basic engineering skill sets. I think Rohit would agree that's something that has got us to where we are today in our careers. Software literacy, obviously, that is something that changes every day. So it will be important for us to stay in tune with what's happening there, and artificial intelligence and machine learning programs, because there's a lot of research currently being pursued in the machine learning algorithms specific to manufacturing. So these are a couple of additions to what Rohit said, which would be important for the students listening in.
Yeah. Yeah.
The next question was, what are the softwares used in digital manufacturing? I think, Rohit, you have already answered that. Anything else you would like to add there?
No, I think yes, there are lots, and it's based on the kind of problem, complexity of the problem, the tool changes, but it's as understanding the basics is important, and tool is something that I always can be picked up, because once you know how to apply it, it's very easy to learn a software. Today we are all learning new things within no time, and products are becoming more and more user friendly and intuitive. So I think that's learning a software is not a challenge, but get your basics correct.
So the next question was career opportunity in digital manufacturing. So I've obviously listed down some things that I could say, but I would again ask Rohit to address this question.
Sure. So when you, as we have given you examples about how companies are getting into disintegrated way of operations, and that's where digital manufacturing will play a role. I think more and more companies are becoming more open towards digitalization, though all this while it was a criteria for them, or it was on their wish list. Now they are moving it from their wish list to the to-do list, and that means that students who are skilled on these areas would start getting, companies would like to look at them, because then their cost on training reduces. And be it on automotive, it is totally, automotive is a very heavy user of digital manufacturing today. uh, Aerospace, yes. Heavy engineering is a heavy user of digital manufacturing tools, but this has been more or less uh, just limited to the OEMs. But I would say that today, with this situation that we are going through, we would see more and more companies utilizing these platforms.
Okay. So this is a very interesting question that is very relevant with a lot of, in fact, our Prime Minister now driving for self-sustenance. There's going to be a lot of focus on the MSMEs. Is it affordable to implement digital manufacturing concept in MSME companies in India? So I know Rohit has been involved in sale of these softwares even throughout his career. So I will mention a couple of my points before I will have him take over this question. I think the answer would depend on what industry and what type of problems are being addressed. So because these digital manufacturing, while it is best to use it for defining manufacturing solutions, it can also be a very vital and viable tool to address burning problems. Okay. So, and small companies, especially when they get hit with some problems, it might be very detrimental to their business. So it depends on what type of problem is being addressed. For example, I'll give you an example where, let's say, there is a small company dealing with some manufacturing of fabrications, critical structural fabrications. And for whatever reason, they come in and then they have a series of warranty claims on them because of structural failures in the field. Because of their, if they are supplying to an OEM, they are bound to take on the warranty cost, which will have an impact on the business detrimentally. So here, they could opt to use digital tools to understand. Let's say if the problem was with the raw material, where they've used a different grade of steel, which is going to be weaker than what it is. So there are tools that can be used from the automation perspective, which would allow for mistake proofing the type of problem. if the welding is an issue, for example, you could now, with today's capability, you could do detailed finite element analysis to the level of modeling the welds, which will actually show you where the root cause of the problem is. So these are, I mean, I'm just telling you some extreme cases where digital tools can be applied, because a lot of times companies battle this. Is it an expensive solution for me? How much is it going to cost me? These licenses are expensive. And today what has happened is even the market has evolved where there are services offered through these software providers. Rather than sell the software, they take up solutions, they provide services to offer solutions. So that's my couple of points onto this question. Rohit, please feel free to add on.
Yeah, so as you told, digital manufacturing, it's about the problem that you're trying to solve. So the size, what is the impact of it? And this maybe it can be looked upon as a consultancy engagement with a smaller company, while the larger companies might have in-house teams for it. But yes, I have been engaged on smaller projects where it is to solve a specific problem, which is more through a consultancy mode. Today, these softwares are also available as lease licenses, which means that companies can start affording it. But of course, the skill set is needed. And that's where if the teams are getting, the students get trained on these, then it becomes more and more easy for them to take up these areas.
So practical application of digital manufacturing in MSMEs, SMEs actually. So I said if it's going to be a very small SME involved with, let's say, machining of components, they have 3 machining centers, but they've been on for a long time, they could actually start looking at creating the 3D library of the components they have done that will help them market themselves better. They could install visual work instructions, which would again drive the better productivity on the line and the efficiencies. They could do visual inspection methods with 3D displays, which would again improve the quality of the product and would attract a wider customer base. They could look at enhancing their capacity to going to demand-based planning and simulating various situations. They could also use digital solutions to have an overall operations management, where day to day, how do they flex their workforce based if they have a change, varying order every day. These digital tools can be used to also define the operator assignment to the areas.
So,
I think there are a lot more questions. I think.
Yeah. So I'm just coming.
Can we discuss that tomorrow?
Yeah.
Yeah, sure. So if time is running out, then we can also take up these questions tomorrow as well. Or what we can do is we would be more than happy to try putting in our views on these questions. And just before we close off, Pratik, I'll just share my slide just for the last bit of it. Okay, so what we are trying as a team of people coming in from a group we have formed, which is a mix of people from domain, people from solution, people from technology perspective, is unriddles.com, and we are going to be more active in this consortium, where we are going to publish information about how you can skill yourself, what's happening in the industry trends, and also different trainings that are going to come up is something that we are going to come up on this platform very soon. So I would request you all to start following our channel. And once you start following our channel, you would start getting a lot of information, and these information would be very helpful for you to plan your next steps. And also feel free to write to us. We are very happy to get engaged on where we help the students on few of the projects that they are doing, and also take these up for the next areas. So here is our email address. So feel free. You can reach to us, and I would be more than happy to have a discussion with you along with Prateek and the rest of the team that we have.
So thank you, sir. Shall I conclude?
Yes.
Yeah. Thank you, sir. The session is very meaningful and very informative. So it's a good time to propose vote of thanks. It's a great honor to propose vote of thanks on this occasion. First, I would like to thank today's resource person, Mr. Rohit Malaya and Mr. Pratik, for their excellent and informative webinar. Sir, your session is really meaningful. Thank you, sir. So I record my sense deep gratitude to our TC management and respective the principal Dr. V. Abhay Kumar, sir, to allow us to continue this kind of webinars. Thank you, sir. I'm extremely grateful to our beloved head of department, Dr. K. Chakulingam, sir, for his continuous support and his guidance. Thank you, sir. I express my sincere thanks to Mr. J. Umar Mohammed, sir, one of the organizers of this webinar, and faculty members of TCE and TC students. Thank you all. Finally, I would like to thank the participants. So all the participants from various institutions and my own TCU for your active participations as well as and involvement. Thank you all. Without your involvement, this program won't get success. Thank you all. We will meet tomorrow same time. Thank you. Thank you all. Thank you, sir. So the feedback link will be sent through mail also. So participants can leave now. Thank you. Thank you all.